Hey guys, welcome back. So what we're looking at today is 8.3, prove it. So for this first part here, we are interpreting tables of values as ordered pairs. So we want to find the value of f of x for the given domain, write x and f of x as an ordered pair. So what that means is we are just plugging in what the given x value is, finding the f of x value, and then writing them as an ordered pair together. So 5 to the power of negative 2 is going to be 1 over 25. So for the ordered pair, we'd have negative 2, comma 1 over 25. 5 to the negative first is just 1/5. So we have negative 1, comma 1/5. For 0, 5 to the 0 is 1. Remember, anything to the power of 0 is just 1. So this is the point 0, 1. 5 to the power of 1 is 5. So this is 1, 5. And 5 to the power of 2 is 25. That's supposed to be a 2. So this would be 2, comma 25. So you'll do the same thing for 1 and 2. You're just plugging in the given x value into the equation and simplifying it down to find out what it equals. All right, the next section, we're looking at identifying specific quadrilaterals. So is the figure at the right a rectangle? Justify your answer. So if we look at the slope of the sides, so P is up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So this has a slope of 4/5. S and R, we go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. This has a slope of 4/5. Now, P to S, we go down 1, 2, 3, 4, 5 over 1, 2, 3, 4. Negative 5/4. From Q to R, we go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4. Negative 5/4. What do we notice about these slopes? They're opposite reciprocals. So PQ and SR have parallel slopes. PS and QR have parallel slopes. And opposite and PQ perpendicular to QR and PS because they have opposite reciprocal slopes, which means that they have 4 right angles. So is the figure at the right a rhombus? How you're going to find this is to find the distance between P and S, P and Q, P and R, P and S. So find out if they are all the same length. So find the distance. So remember, we can do 4 squared plus 5 squared equals C squared, and that'll give us the distance. And if all these numbers are the same and we ignore negatives, are they all the same? Yes. All have the same length. 4 squared is 16 plus 25, which equals 41. So the square root of 41. So yes, it's a rhombus. Now, what you need to figure out is if it's a rectangle and a rhombus, does that make it a square? That's what you have to figure out. All right, the last section is find the perimeter of each below, round your answers to the nearest hundredth. So what that means is you need to find the distance and length of every single side and then add them together. Now, for 7, this one's a nice and easy one. We just need to figure out what the radius is. So 1, 2, 3. The radius is 3. So circumference equals 2 pi times the radius, which is 3. So circumference equals 6 pi. So it is 18.85. Now, on this one down here, finding the radius is a little more tricky since it's not right on a grid line, but you'll do the same thing up here, but then divide by 2. But remember, distance formula is what you're going to need for this. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So the one we're going to look at is this one down here. We have a side of 1, 2, 3, 4, 5, 6. So there's a side of 6. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is 12. Now, to find the diagonals, so this is at the point -6, -3. So you've got -6, -3. And this point up here is -4, 2. So use our distance formula. So we have -4 minus -6 squared plus 2 minus -3 squared. -4 minus -6, so really -4 plus 6 is going to give us 2 squared. 2 plus 3 is 5, so 5 squared. So 4 plus 25, which equals 29. Square root of 29 is 5.38. So now we know 3 of our sides. Now we just have to find the last one. So I'm going to erase this so I have some more space. All right, so the last one, we have a point at 2, 2. And our other point is at 6, -3. So set up our distance formula. 6 minus 2 squared plus -3 minus 2 squared. 6 minus 2 is 4 squared plus -3 minus 2 is -5 squared, which would just be 25, and 4 squared is 16. We can just go ahead and write that. So 16 plus 25 is going to give us 41. So we have the square root of 41, and the square root of 41 is 6.4. So now we add 5.38 plus 6 plus 6.4 plus 12 together, and we get 29.78. So we just add all the sides together, okay? So you'll have to do the distance formula a lot of times. This is going to give you a lot of practice finding the distance formula. All right, your keyword for this lesson is quadrilaterals. Quadrilaterals. If you have any questions, feel free to ask. Have a wonderful day. Bye, guys.